Okay, going to do some practice problems off the packet called 4.8 worksheet number 1, and that's a whole bunch of word problems, and they are problems about trig, and if you get the triangles drawn right, it really isn't that bad. All right, this first one I'm going to do is number 23. It says a guy wire, which is basically a support wire, connects the top of an antenna to a point on level ground 5 feet from the base. All right, here's my tower. Here's my wire going down to the ground. How far is it from the base? 5. And now, the angle of elevation, there's only one angle of elevation here. An angle of elevation looks up. So if I'm doing it from here, I'm not doing it right because I'd have to look down from that line. So I must be doing it from here. And there's only one angle of elevation here because this one's a right angle and I know it. It's got to be 90. You don't make towers that go, we're not going to make any leaning towers of Pisa anyway. So that's got to be 90. So then this must be the one that's the angle of elevation. And that angle right there is 80. So this must be an 80. How many of you had your triangle set up right? Raise your hand if you did. Good. From there, it should be a piece of cake. My choice is to either figure out the height or the wire. I'm going to go with the height of the tower first. And that means I'm going to do tangent of 80. Now, how did I know it was tangent? Because I knew I had to use something that didn't have the hypotenuse in it. Because I don't have the hypotenuse. So tangent's the only thing that doesn't have the hypotenuse. Tangent is opposite over adjacent is h over 5. So if I figure out tangent of 80 and then I just times by 5, I'll have my answer. What did that one come out to? 28 point what? 28.36? Awesome. Then the other one is the same basic thing, except I want to figure out this. I'm going to call it W for the wire. So I would say that one does have the hypotenuse. So I'm going to go sine, or maybe I should do cosine because you're going to use the 5. That's a nicer number than 28.36. So I'm going to do cosine of 80, ka, adjacent 5, over hypotenuse, W. So I figure out cosine of 80. I multiply both sides by W. And then I end up dividing by cosine of 80. And the final answer will be W equals 5 over cosine of 80, whatever the heck cosine of 80 is. So that came out to 28 point what? 79. All right. Any questions on those? How many of you had it right? Raise your hand if you did. Good. There's still hope for you. If you didn't get that right and you totally understand what your mistake was, then you're fine. But we have a lot harder ones to do. Let's do number 24. Number 24 is a nested triangle, and those are the harder kind. Let me give you some examples in general. You're flying overhead in a plane, and like that flight that's missing over the, well, we don't know where it is. It could be anywhere, maybe the Indian Ocean probably. That's where they think it is, right? At first it was the China Sea, and then I think they figured out it's probably not there. It must be Indian Ocean. Anyway, if that plane is looking down and seeing something in the water down here, maybe it's one of the search planes that's overhead looking for people. Can you imagine what insane news coverage there would be if they found a life raft with people in it? Because that's what they're really hoping for. Is if it crashed, there's a chance that it crashed and some people would have survived, and because it does happen sometimes. So, and then let's say that there's another raft that's like right here. And they've got then therefore two triangles. There's the black triangle I'll make with black dotted lines. And do you get that there's the blue triangle that I could make with the blue dotted lines? Nested triangles. Now, what I recommend on nested triangles is first that you figure out what you want. And in this kind of problem, you want to find the distance between the two ships usually. So to get that distance, I need to have two separate triangles drawn. I'll draw one in solid black lines here. And then I need to draw the other one in the blue lines. And then I figure out that I need to find the difference between the longer one and the shorter one. I take the longer one minus the shorter one. So I got to figure out the black one here. I got to figure out this side right here. And then I got to figure out this blue side right here. And then I got to subtract them. That's kind of the big picture of a nested triangle situation. I'll give you another one. You're standing on top of a building. And here's a friend who's standing over here on a taller building. All right, and you apparently have scoliosis or something. Anyway, and then you're looking between you and the friend. Do you get how I could make a triangle like this? And I also could make a triangle of you looking down at the ground here, like this. There's another nested triangle kind of situation. Here's another one. Let's say I just get back to the two friends again. Not going to complete that one. Let's say we have another one like this, and this, and this, and this, and let's see. How else could I nest the triangle then? I could even do, you sight first of all to your friend's foot, and that's a certain angle. Then you sight to the top of their head, and that's a different angle. There's again two nested triangles, and in this case it might be like you can figure out how tall your friend is. This height right there. So in the end, to find that height, you'd probably find the bigger height minus the smaller height. But it's all about setting up the nested triangles. All right, so now that you know how a nested triangle thing kind of looks, let's look at number 24 and see if you can draw that situation. Sadly, we have a very small amount of space underneath number 24, so you're going to have to not make any mistakes on your drawing, or do it in pencil and be ready to erase. Okay, so let's get the big picture before we start drawing anything. These guys are standing out on a roadway, and there's Mike and there's Dave, and one of them's got a long pole in his hand, and the other one is sighting in on that pole. All right, so I'm going to say here's the ground, and here's my guys. One guy, another guy, and this guy's got the long pole in his hand. Okay? Now, do we know any of these distances yet? 80 feet between them. Dave walks 80 feet from Mike and holds up a long pole. So this must be Dave. And therefore, this is Mike. Mike looks at the pole through a sighting instrument, looking straight across, parallel to the horizon. Mike sights a point on the pole 50 inches above the ground. Call it A. All right, so this is a point 50 inches above the ground, and that's A. And this is 50. And that's in inches, by the way. Then Mike holds the instrument, or looks through the instrument at the bottom of the pole, creating an angle of depression. Aha! So here's his first sight-in line. And then he's looking at the bottom of the pole. There. Creating an angle of depression. It does. See, angles of depression, you start with the horizon line, and then it goes down from there. And then this is the angle of depression. It's going down like that. Because like you're depressed, you put your head down. It's like going from up to down. All right, so then it's like this. That little angle right there is, what did it say? Did it say how many degrees it was? Oh, okay. I guess they're going to probably make us figure that out. All right. So now, do you get that I've got a triangle and I know two sides of the triangle? I know. I'm going to just zoom in on just the triangle here. Wait. Raise your hand. And this is 80. And this is 50. And I want to know that angle right there. Yes?
So we assume that Mike is perpendicular to 50 inches?
It did say that this line of sight was perpendicular to the horizon and therefore a straight line straight across. Read it. Yes? Yes, we do. We do need to fix that 80 and 50 and so make them into the same units. You're correct. Do you get from reading it before that this is a straight line across parallel to the horizon, this line right here? Because that's important. Otherwise, we wouldn't have a right triangle. Okay, so anyway, if this is 80 and this is 50, it'd be really nice if they were both in the same unit, but they weren't. One was in feet, one was in inches. So we need to change that. So you go 80 times 12, 960, thank you. 960 and 50 are my two numbers now. So now, this one wasn't even a nested triangle. It was a little bit complicated to draw the picture. Now that I have this picture in a triangle, isn't it? I hope from here it's easy for you. You should be able to say, well, I don't know what this, I'm going to call it theta. And then I'm going to say it's tangent or cosine or sine, but wait a minute, I don't have the hypotenuse. So I better not use anything except tangent, because tangent's the only one you can do without the hypotenuse. So tan of theta is equal to, tangent is opposite over adjacent. Opposite is 50 over 960. And then I'll get some decimal for that. And to solve this, I need inverse tan. My best advice on this kind is to do this. Get rid of tan with inverse tan, like this. Inverse tan here and inverse tan here. And then these cancel. And you can tell just by logic that it must be inverse tan of 50 over 960. As opposed to you just trying to guess that that's the number you better do inverse tan on. This is why, because you take inverse tan on both sides. So final answer is, what is the inverse tangent of 50 over 960? And I think it was like 2.9 or something like that. 2.98. So theta equals 2.98. Good question. These are all real world problems, and most people in the real world talk in terms of degrees. People are expecting degrees. Now, if you answered in radians and the directions were not clear, I would have given it to you. But just like before, I said pretty much you want to default to radians. These kind of problems, pretty much you want to default to using degrees. But, one exception. If you're doing a pendulum kind of problem, or any kind of a circle kind of problem, there's one in today's homework about your hands are at 2 and 10 on the wheel on a circle, on the steering wheel. If you've taken driver's ed, you probably know your hands are supposed to be 2 and 10 on the wheel. And then you figure out how many degrees that is, and you're like, oh, this must be one of those S equals theta R questions. And you're right. But that's the case where you don't want to use degrees, because you can only use radians in this formula. Remember that? Okay, so if you're doing this formula, don't try to do it with degrees. Theta is in radians in this kind of a problem. And then I think what they ask you is something to the effect of, you have to figure out that this angle comes out to 90, and then you're told that the steering wheel is a certain size, so that this is like 8 inches or something like that, and then you just stick them in. You go, I don't know what S is, but I know theta is 90 degrees, and why would I be getting it wrong right now? Because it's not in radians. So I'd have to change 90 degrees to what over what? Got that one memorized? Pi over 2. Now it'll work. So that would be 8 pi over 2. That'd be the same as 4 pi. And if S is a distance, it's 4 times 3.14. So it's about 13 inches or so from here to here, because it's 4 times 3.14. Okay, so the point is, I was trying to say usually use degrees, but this, if you're using this formula, you got to use radians. All right, so back on that Dave and Mike problem, there really wasn't even a nested triangle on that one. So I want to go to one where we have a nested triangle. Number 25. Everybody look at number 25 with me. I'm doing your homework for you. What a deal. A person standing 110 kilometers from a hot air balloon watches it rise. All right, I really do recommend you draw an actual, don't just make it a triangle. Start with a person. Here's a person. Doesn't have to be pretty or anything, but here's the hot air balloon. And then it's rising, right? So then another way to think of that is the hot air balloon goes up there. So it's like going like this. Now it says they were 110 kilometers from the hot air balloon. That is the bottom of my triangle. Watch as it rise vertically. Okay, so that rising is, this rising is happening straight up and down. That's what that means. Its angle of elevation from the person to the balloon changes. Well, it's changing because it's rising, right? This angle of elevation started at 19, and that's the black triangle. And it changes to, note the nesting of the triangles, this angle, which is 38. Now, because of the fact they're nested, it can be confusing. But what we want is to figure out this distance right here. So what we really need is to figure out this whole side, the longer side, and then the shorter side, and we just subtract them. So what I would do is I would make two triangles. I would explode out my, my nested triangles into two triangles. I'd have this one, the blue one, where it was 19 and 110, and I got to figure out x. And then I can have the black one. Actually, I should have done that one in black. I'm going to do that one in black because that's the black one on the other picture. Okay. And then the blue one is the bigger one. And that's 38 and 110. And maybe we could say y. If we figure out x and y and subtract them, then it'll be easy from there. So sine, cosine, or tangent. Do I have the hypotenuse? No. Tells me I should probably use tangent. I use tangent a lot in these problems. Tan of 19 is equal to x over 110. Then you figure out tangent 19 times by 110. This other one, tangent of 38. Tangent's opposite over adjacent, y over 110. So I'm multiplying tangent of 38 times 110. Take those two numbers, subtract them, and you'll have it. Nested triangles. Let's look at another nested triangle situation, number 26. First, get the big picture of what we're talking about. Are we talking about like lemurs on a hillside, or what are we talking about? Number 26. Lori spots a hiker. She's on top of a cliff. Okay, so I got to have somebody up on a cliff, and they're going to spot a hiker at an angle of depression of this, another hiker at an angle of depression of that. Okay, so she's up on a cliff, so I'm going to make a cliff. They kind of generally look like that. And here's my person up on the cliff. And they're looking down. I know that because this is angle of depression. And this is a 35-meter cliff, so that's 35. And they're looking down, so then here's horizontal. We need the horizon line to figure out the angle of depression. She's looking down, and one of the angles is 62. That's, let's say this is 62. And if that's 62, the rest of it would have to make a total of 180, right? No, sorry, total of 90, so 28. Another hiker at an angle of depression of 30 degrees. The other hiker, it's only an angle of depression of 30, which is about half as much. So she's looking at this other hiker is over here. Here's a hiker 1, here's hiker 2. This is 30. Curved a little bit there, didn't I? Straighten that out a little bit. So there's a hiker there, there's a hiker there. All right, there's nested triangles. There's that triangle. There's that triangle. And I bet you they're going to ask us the distance between the two hikers. Yup. What is the distance between the hikers? Same basic problem as last time. Got to take the long distance minus the short distance. And what did I say to do with nested triangles? separate them out. Make two. So I make my one triangle that's like longer like this. The other triangle that's like shorter like this. And I say, okay, one of them's got an angle of 28. And the other one's got an angle of whatever. What does this have to be? 60, I guess. And then they both have a distance of there, both 35 feet up. And then I got to figure out the difference between this distance and this distance. So I'm going to call one of them X and one of them Y. And then you just subtract the two. So that's the best help I can give you. I mean, of course, I can't tell you how to solve every problem on the test, but I can tell you when you have things that are nested like that, try to pull them apart. Do get the difference between, here's one of the most important things. If I say angle of depression, elevation ones are easy. Because if you do an angle of elevation, you're just going up, and that is the angle. If it says angle of elevation is 30, this is 30, you're done. But if you're doing an angle of depression, a lot of people get confused by that, because then if they say the angle of depression is 25, people will go like that, and they'll draw their triangle, and they'll get confused and think that this was 25. Which one's 25? If it's an angle of depression, is it the red one or the black one? It's the red one. If it's an angle of depression, it's like that. So then if there is a triangle like this, that's not 25, that's got to be 65. Get the difference? The angle 25 is the angle of depression, but the angle 65 is probably what you'd actually use in your triangle. Unless you want to make your triangle this way, and then you could use the 25. But obviously that triangle's flipped, different. You could use the green one or the black one. Just don't get them confused. Okay, so I wanted to give you a bunch of time to work now. You've got the rest of the problems to do to practice. The answers will be posted tonight. And if you have questions, come on up and ask. Please study for this one, for your own good. And you won't have as much, if you really work hard tonight and get a decent grade on this, you won't have to worry about retaking it later on the cumulative. Otherwise, if you don't spend the time tonight, you'll probably still have to spend the time like 3 weeks from now when you're studying for the cumulative on this. All right.